we present SCOPS, a method for self-supervised copart segmentation. In computer vision tasks, object parts are good representations because they are robust to variations including appearance, camera viewpoints, and object articulation. The part information could also provide rich intermediate information for many high-level computer vision tasks, such as figure recognition, object detection, pose estimation, and 3D reconstructions, to name a few. However, it is often expensive to annotate object part information, especially for the part segmentation. Therefore, in this work, we aim to learn the object part segmentation with a self-supervised way without any annotation, given an image collection that contains similar object instances. Here we show the proposed framework. We use a fully convolutional neural network to generate part segmentation, and we devise several constraints, including geometry concentration, equivariance, as well as semantic consistency, to train the network to discover semantically consistent part segments. The first constraint is geometry concentration. Since the part pixels are locally connected together, we design a concentration loss that encourages the pixels to be close to its part center. The second constraint is equivariance, which means that the part segmentation should be robust to spatial transformation and appearance perturbation. Therefore, we randomly sample the spatial and color transforms and apply them on the images. And the equivariance loss would push two part segmentation to have consistent results with respect to the spatial transform. Here we show the visual differences of the segmentation results. Note that the hair and other parts are more consistent after applying equivariance constraint. To ensure the discovered parts are semantically meaningful and consistent across instances, we also propose a semantic consistency constraint. We use the pre-trained image network to extract the intermediate target feature maps, and we also train a set of semantic part bases, where each basis represents the ImageNet feature of the corresponding part. Then we linearly combine the semantic response and the semantic part basis to reconstruct the target feature maps. We know that without the semantic consistency loss, the learned part segmentation would not correspond to meaningful parts such as eyes, hairs, lips, or nose. We conducted experiments on 3 datasets. Here we show the results on an aligned human face dataset and compare with existing works. Both the quantitative and qualitative results show that SCOPS performs favorably against the other methods. Here we show the comparisons on the bird dataset, which contains highly articulated birds. Note that the proposed method has much fine boundaries as well as semantic consistency across instances. Finally, we show the results on the horse images of the part-scale part dataset. SCOPS can also work well on other common object categories. We also show here how the learned part basis improves over training process. The top images show the part segmentation results, while the bottom show the TSNE visualization on the ImageNet features of pixels and their corresponding segmentation class. The white dots represents the background pixels. During the training process, we can see that the part segmentations are improving, while pixels with similar ImageNet features are segmented as same class. In summary, we propose SCOPS, a self-supervised technique for part segmentation. Given an image collection of object category, SCOPS can learn to predict semantically consistent part segmentations without using any ground truth annotations. We hope that the proposed method could serve as a general framework for learning copart segmentation. Please see the paper for more details. Thank you.